Okay, the third example for determining rate law, and this one actually asks what is the rate law and what is the rate constant. Okay, so the same exact process. The generic rate law is going to be rate is equal to K times concentration of A to the M, B to the N. So I have to find M and N. Okay, so I'm going to do the same thing. Okay, I'm going to look for the one that's different. Well, this one's different. So it can either be 1 and 3 or it can be 2 and 3. Okay, then I have to go over here. So for M, it can be 1 and 2 or 2 and 3. Okay, so when I look at 1 and 2, they are the same. So this one works. And really, I don't have to go any further than that. If I found one that works, I don't have to, but just to show you that 2 and 3, they're not the same concentration. It does not work. Okay, so the highest concentration goes on top, which is this one is 2. So it's going to be the concentration of A for experiment 2 over concentration of A for experiment 1 raised to the M is equal to the rate for experiment 2 over the rate for experiment 1. Now I put in my numbers. I have 0.10 divided by 0.05 to the M is 8.0 times 10 to the minus 3 divided by 4.0 times 10 to the minus 3. And again, when those are the same, so 0.1 divided by 0.05 is 2, so I have 2 to the M, and I have 8 divided by 4 is 2. So here's my first example, M is equal to 1. Okay, and I come down here and change colors. All right, and so for N, okay, the one that's different is 3, so it can be 3 and 1, or it can be 3 and 2. Okay, so 3 and 1 have the same concentration there, so that one actually worked. 3 and 2 have different concentrations, so that one did not work. Highest concentration goes on top, so therefore it's going to be the concentration of B for 3 over B for 1 to the N is 1.6 times 10 to the minus 2 divided by 8.0 times 10 to the minus 3. Oops, that was not what I meant to write there. Okay, sorry. It should be the rate for 3 over the rate for 1. Now I will put in numbers. So I have 0.1 divided by 0.05. I have 1.6 times 10 to the minus 2 over 8.0 times 10 to the minus 3. This is to the N. So I have 0.1 divided by 0.05 is still 2. I have 1.6 times 10 to the minus 2 divided by 8 is 4. 8 times 10 to the minus 3. So N this time is 2. So my rate law is equal to K times concentration of A times the concentration of B squared. Okay? And to solve this for K is going to equal, let me change colors again. So K is that one. K is going to be the rate divided by A divided by B squared. So for K for 1 is going to be 4.0 times 10 to the minus 3 divided by 0.05 and by 0.05 squared, and I get 32. These are very artificial numbers. You notice that these were exactly 2 and exactly 4, exactly 2 and exactly 2. So actually it turns out that K2, K3, and, oops, that's all of them, also equal 32. So the average K is equal to 32. Okay, and so you can actually plug in the numbers for K2 and K3 to try them, but they're both equal to 32. And so the answer is, the average K is 32. Now, like I said on the test, I will only ask for you to do 1, because if you know how to do 1, you know how to do 3 or 4 of them. And so I don't need you to show me all that. So on the test, it'll usually say what is the rate constant for one of the experiments. And it doesn't matter which experiment you choose to do. And this is the end of determining the rate laws problems.